Hello everyone, welcome to my YouTube channel. This is our module 2 of course Machine Learning from Basics to Advanced. In this module, we will deep dive into supervised learning algorithms. Let's recap the previous modules. In module 1, we have learned the concepts of supervised learning, unsupervised learning, reinforcement learning. If you haven't watched this video, I'm leaving the link of that video in my description box. So, let's talk about supervised learning algorithms. We have following main supervised learning algorithms, and in this video I will cover linear regression algorithm. So, what is linear regression? This is one of the most basic and widely used algorithms in supervised learning. It's perfect for predicting continuous values. But what does that mean? In simple terms, the linear regression helps us find a relationship between two variables. Let's call them x and y. Imagine you are trying to predict something like how much money someone will earn based on how many years of experience they have. You have a bunch of data points for different people and you want to find a pattern. That's where linear regression comes in. It looks like all the data points. Let's look at all the data points and tries to draw a straight line that fits through them. This line represents the relationship between experience and earnings. The closer the data points are to the line, the better the prediction. And if the line is good, it can help you predict someone's earning even if you have never seen their data before just by looking at their experience. Now let's dig a bit deeper into what we mean by linear in linear regression. When we say something is linear, we mean that the relationship between the input, which is x, and the output, which is y, can be represented by a linear line. The equation for this straight line represents equation for linear regression with one input feature, y equals to b naught plus b1x plus e. What do all these variables mean? B naught is the intercept, that is where the line crosses the y-axis. It is the value of y when x is 0. B1 is the slope of the line. This tells us how much y changes when x changes. For example, if B1 is positive, it means that as x increases, y will also increase. E is the error term. This represents the little difference between the input data and the predicted value. No real world data is perfect, so this error term helps us adjust for that. On the graph, you will see that the intercept is where the line hits the y-axis and the slope determines how steep or flat the line is. Together, these components help us predict the value of y based on any given x. Alright, so let's dive into the cost function and why it is important in linear regression. Essentially, the cost function is what helps us determine how well our linear regression model is performing. It measures the error or the difference between the actual values from the data and the values that our model predicts. The most common way to calculate this error is by using the mean square error formula. Here is the mean square error formula where m is the number of data points, yi is the actual value, and yi hat is the predicted value. In simple terms, for each data point, we calculate the difference between the actual and predicted values, square that difference, and then take the average of all these squared differences. Now, where do these predicted values come from? They come from linear regression equation, which in its general form looks like this: y equals to b naught plus b1 x1 plus b2 x2 plus continue plus b and xn plus e, where b naught is the intercept, b1, b2, and so on bn are the weights or coefficients for the respective input features x1, x2 till xn. E is the error term. The goal of the whole process is to find the best possible values for these coefficient b's such that the mean square value error is minimized. In other words, we want to adjust the weights and bias in such a way that our model's predictions are as close as possible to the actual values. Now, let's solve linear regression with one variable numerical. In this example, we are trying to predict salaries based on experience. We have data sets which contain 5 data points. We will use ordinary least square method to find optimal values to weights and bias in order to minimize cost function. This is our intercept and bias equation, where B1 is the weight, B naught is bias, and represents the number of data points. So proceeding further, we have calculate summation of x, y, x square, x, y of our data set. Putting this value in our formula, we will find values of weight and bias. Thus, we will get best fitted linear equation for our data set. Please note that it is not necessary that this line will pass all the data points and accurately predict each data points. However, this line will give us the best equation and the least mean square error, which is our goal. Now solve this example with Python code. In Google Colab, we will first import libraries such as NumPy, Matplot for plotting, Skylearn linear model for linear regression. We will store our dataset in array form and apply linear regression model to find best fit. Here we have defined um, intercept and slope and write print command to print our linear regression equation. Model will predict y based on input feature x. We have write code to plot x and predicted y. You can see the equation of best fit is same as we have find out from our manual method ordinary least square. This is our plot. In this plot, the line passes through all points. However, in general, it is not the case because we have in this case we have less data, and when we have more data, line try to pass as many points as possible. I suggest you people try this code for large data set and find the best fit. So that's all for today. Thank you for watching. If you like this video, thumbs up and subscribe to my YouTube channel for more videos.